Exercise 1.2, question 2. Find the LCM and HCF of the following pairs of integers. So every time you have two integers given, you have to find their LCM and HCF, and then you have to verify a result. A result that is true, you just have to verify it that the product of the LCM and the HCF is equal to the product of those two numbers. So what this means is, let me just take a very simple example. Suppose my numbers are 2 and 4. Now, what is the LCM of these two numbers? The least common multiple. That is 4. And what is the HCF of these two numbers? That is equal to 2. So, that is the highest common factor. Now, the product of the LCM and the HCF is 4 times 2, 8. And also the product of the numbers that you're working with, 2 and 4, that is also 8. So in this case, you saw exactly 4, 2, 4, 2. It's not necessary that it's going to be that, but the product is definitely going to be the same. Now this is what we have to verify for these pairs of numbers. So let's just get started with them one by one. Alright, here's part 1. We need to find the LCM and the HCF of these two numbers first of all. Now how do you find that? You've done that in junior classes, but let's just discuss that one more time. For that, you first need to prime factorize each of these numbers. So suppose I want to find the HCF first. So I will prime factorize 26. Now I can either do that using the factor tree, or I can write it this way, whatever method you're comfortable with. Let's use the factor tree for now. Okay, so this is 2 and 13 and both of them are now prime numbers. So 26 can be expressed as 2 times 13. Similarly, when I work with 91, I will see that this is 7 times 13 and both of them are prime numbers, so I can't do anything further. Now that I have both the prime factorizations, how do I get the HCF? The HCF really is the common factors that these two numbers have, and it's the highest common factor. So here when you see these 2 and 7 are not common at all. 13 is the common prime factor that they have, and the power on 13 is 1 in both of them. The rule is that you take the common factors along with the lowest power that you see. For example, if one of these numbers was 2 times 13 squared and the other was 7 times 13, even then the common prime factor would still be 13, but I would take it with the lowest power. So the lowest power is 1. So even then my HCF would have been 13. In this case though, both of them have the same powers. So the HCF of these numbers is 13. Now let's see the LCM. Okay, for the LCM also you do need the prime factorization, but this time you use it differently. To show you the contrast, I've written what HCF was. In HCF what you had was product of the smallest power of each common prime factor. So you only take the common prime factors and their smallest powers. Let me also write what you do for LCM and then we'll calculate it. There you go. It says you still take the product, yes, but it's the product of the greatest power this time, and that too of each prime factor. Just notice how we no longer have the word common. So it's not just about the common prime factors, it's about every prime factor that you see. So when you look at that carefully, the LCM for me is going to be, look carefully, what are the prime factors that you see? You will see 2 and 13 in 26 and 7 and 13 in 91. So all of them will definitely be a part of the LCM, and that too with their greatest visible powers. Now the greatest power that you see on 2 is just 1 because it's just here in 26. The greatest power on 7 that you see is also 1. It's just a part of 91. And the greatest power that you see on 13 is also 1. So in this case, it's just the product of 2, 7 and 13 which will give you the LCM. So this is equal to 182. So that is our LCM. Now remember what we had to do. We had to verify a result which is stated in the book as this. It says for any two positive integers, It says that for any two positive integers a and b, the HCF times LCM will be equal to a times b. So product of HCF and LCM is equal to product of the numbers. That's what we had to verify. Now that we have the HCF, we have 13 here, and we have the LCM 182, let's just quickly check the product. Okay, when you will multiply 13 with 182, do that multiplication yourself, you will see it is 2366. And when you will multiply the numbers that you have, 26 and 95, that will also come out to be 2366. So we have verified the results that we had to for part 1. Now let's go to part 2. Please pause the video and try this before you see my solution. The steps are again to prime factorize each number, to find their LCM and HCF, and then to just check the products. Here is stage 1. The prime factorizations are done here. Now I will just write down the HCF. The HCF is what again? It's only the common prime factors with the lowest powers. So what is common? I can see 2 common. Yeah, and nothing else. This one has 23 and this one does not. So 2 is the only common prime factor. And what is the lowest power on that or the greatest power? Remember the rule. You take the smallest power here. So the power on this side is 1 and the power on this side is 2. So the smallest one is 1 and therefore 2 is your HCF. Next, when you look at the LCM, you know this time it's not just about common prime factors, it's about every prime factor that you see, and that too with their greatest powers. So 2 will come with a 2, 3 will come with the only power it has, which is 1, 5 will come with the only power it has, 17 as it is, and 23 as it is. So this is going to be the LCM. Now finally, checking that product of LCM and HCF is the same as product of these two numbers is very simple. So I leave that to you. We will go now to part 3. So this here is part 3. Again, pause the video, prime factorize this, and then play. You'll see my prime factorization. Then we'll write HCF and LCM together. All right, here are the two prime factorizations. Just check that you have exactly the same in both of them. If not, pause and retry one more time. Now, if you get all of this correctly, then writing the LCM and HCF is straightforward. So LCM is going to be every single prime factor, and that too with the greatest visible powers. So 2 will come with the greatest power, which is here, 4. Then 3 will come with its greatest power, which is 3 from here, and 7 is just going to come with a 1. Similarly, the HCF, it's only the common prime factors first of all, and that too with the lowest powers in each case. So let me just clear up these arrows that I've made and let's try to highlight one more time. First of all, which ones are the common prime factors? The common ones are just 2 and 3. So this time the 7 will not come in the HCF. So 2 will come and 3 will come, and both of them will come with their lowest visible powers. So 2 to the power 1 from here and 3 to the power 1 from here. And now again, now that you have the HCF and the LCM, the final step of checking that the product of HCF LCM is equal to the product of the numbers is easy.